Hey, grade nines. Okay, so this is lesson 4. We're going to graph complex inequalities in boundary points. Now, by complex, I'm actually just saying the difference between simple and complex is simple as one boundary point, complex will have two. Okay, let's look at this first example. It says the skating rink is only open if it's colder than 0 degrees or warmer than negative 20 degrees. All right, so we're going to let's go with a bright color here. So we're going to talk about T for temperature. All right, so T stands for temperature. Okay, so in one instance, the skating rink, look what it says, is only open only if it is colder than 0 degrees or warmer than negative 20. So T definitely has to be less than 0 degrees. It's not zero, it's not less than or equals to, it says colder than 0. So exactly 0 is not acceptable. It's just less than. Now, on the other hand, so again, I was talking about these types of questions are like a Goldilocks zone. There's a Goldilocks zone of temperature. On the other hand, the temperature also still has to be greater than negative 20. Okay, so let's see what this looks like. Okay, I'm just going to bring this up a little bit. All right, so let's just call this, we know that we're dealing with a lot of the negative temperatures over here, so let's be smart about this and maybe put 0 over here. Okay, I'm not going to mark all these, I'll just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so there's negative 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, so there's negative 20. Okay, so here's what you're going to do. Just do them separately. Just do them individually, and then you'll see how to bring them together. So if temperature has to be less than 0, okay, so then we got to start with an open boundary point, and it's got to be an open boundary point here. Now, on one hand, it's got to be less than 0 degrees, okay? However, it's not going to go infinitely in this direction in a negative temperature. In other words, you're not going to be skating at minus 120 degrees. The arrow can't continue on forever, okay? So again, we start at 0, open boundary, right? So this is open, and this is open, okay? All right, do not shade the surface. So on one hand, this is going to go like this. On the other hand, it also has to be warmer than negative 20, so these arrows will collide. So there's no need to draw an arrowhead at it anymore. You actually are just drawing one solid line between the two boundary points. And that's how you do a complex question, all right? I call it complex because it's not as simple as dealing with one. Okay, so that's how you do it. You really just got to decide what you have, right? So you have a boundary point here. Let me just make a point here. So you got a boundary point here, and we're saying a boundary point here. Okay. So we are saying the temperature in this range, okay, is acceptable. All right. That's where the solution. So you could have minus 12.1. You could have minus 8.6 degrees out, right? You could have minus 19.8. These are all good to go, okay? So you're good to skate. Now, on the other hand, you know what's coming next. I'll switch to my gray, and I'll go, you're not skating here. The solution does not exist past your boundary points. This is too warm over here. So this is almost like truly Goldilocks. This is too warm, this is too cold, and this is just right, okay? This is just right, all right? Just right. Okay, I think I've made my point. So the complex questions have two boundary points. Next question. So the level of water must always be between 8 meters and 15 meters. Oh, I can't do that, can I? Because I made him fixed it. That's okay. So 8 meters and 15 meters. So the water level height, let's say the height, has to be between 8 meters. Technically speaking, exactly 8 meters is not allowed. It has to be greater than 8 meters. And then again, on the other hand, it has to be less than 15. So let's start marking some boundary points. Let's go, I think we have enough room here. 6, 7, 8, 9, 10, 13, 14. Yeah, we do. 15, 16, 17, 18. Okay. So on one hand, the water level has to be greater than 8. Okay. Not a great arrow. Now about arrows, yeah, you can just overcolor the number line, or you can kind of go up and across like this. Okay, it doesn't matter. If you look at the textbooks, they try to color over the number line. All right, just a little bit. Of course, I'm kind of a spaz. Then over here, another open boundary point at 15, and that would go this way. So the two arrows crash. And it really is a lot easier to just do a thick straight line, right? Doesn't that look a little bit better? That looks a little bit better. And that's your solution, okay? The level of the water must be between, so we've shown it between. Again, where's your boundary point? Right at 8, right at 15. Sorry, it's not exactly on 15. Okay, so we're good. Whoops, gotta get off the... we're good here, and we're not good here. The solution, okay? There's your boundary point. Sometimes you'll see them labeled as BP. Does not stand for Boston Pizza. Okay, next one. Let's use orange. Okay. Fish must be between 20 centimeters and 40 centimeters. Okay, I know that's going to be way too thick. To keep them, okay? It must be between 20 and 40. Okay, so, let's call this 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's my 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 19, 20. So there's 40. 2, 3, 4, 5, 6, 7, 8, 9. I can't wait to really mess up on my counting once, and then you guys will point it out, of course. Okay, so the fish, we're talking about length. Okay, length. So the length, L stands for length. Okay. The length of the fish, by the way, this is called a slot size. This is a real life thing. So the length, you can't keep anything under 20 centimeters, but on the other hand, you can't keep the super trophy size fish either. So they've got to be, L has got to be greater than 20, and it's got to be greater than 40. Okay, so boundary point here and a boundary point here. So this time I will be a little bit more clever, and I will use a straight line to connect those points, and I'll make it a little bit thicker. And we'll start right here. And I'll go right to 40. Look, that's a little bit nicer, right? That's your solution. So once more, right? If we're going to talk about boundary points, let's delve into it just a little bit deeper. So boundary point here, again, I'm not being super picky about whether they're totally straight. But any fish caught between here, okay, is good. So you might catch one that's 21.1 centimeters. You might catch one that's 39.9 centimeters. You might catch one that's 27.5 centimeters. These are all acceptable sizes. This is breaking the law, you'll get a ticket. This is breaking the law, you'll get a ticket. All right. Okay. All right. The tire pressure must be at least 34, and no more than 40. Okay. So it'll be a little bit different here, I think. Just pause quickly. Is there going to be a little different in terms of our boundary points? We'll see. So the pressure must be at least 34. So that would be greater than or equal to 34. And it has to be no more than 40, which means if you nail 40 exactly, that's still acceptable. So this case, all right, little comma here. So the pressure has to be greater than or equal to 34. It has to be less than or equal to 40. Okay, so then let's start with, we should have enough room. 32, 33, 34, 35. Oh yeah, we easily have enough room. 36, 37, 8, 39, 40, 41. So, I'm a little off center here. Do you see why you got to try and make it as best as you can? Doesn't matter. All right. I'm going to use just a slightly different color. So boundary point on the left, boundary point on the right. And guess what we get to do? That's right. We get to color these in. Okay. We get to color these in. Now, again, that worked last time pretty good. So let's do a little bit of a thicker line. And let's connect our boundary points. Okay. Now, of course, that means any tire pressure, right? So this is what we're talking about when we say, so this is our, right, between. Okay, just going to decrease this thickness. This is between 34 psi and, what did we say, 40? 40 psi, okay? Right, so over here, you're getting a little bit flat tire syndrome here. And over here, you're overinflated. You could burst your tires. Okay, overinflated. All right, the golf course is, you guys, I think you're getting the idea. Look, if you get the idea, I assume sometimes you're not watching the entire video, but unless you're looking for entertainment value, which means you have no life. The golf course is only open if the temperature is 5 degrees or warmer. So temperature has to equal 5 degrees, or it could be warmer. But then again, they don't like scorches, and it has to be less than 40. Oh, this is a good one, because look, on one hand you have greater than or equals, but this one is just less than. So let's mark these off quickly. So 1, 2, 3, 4, 5, 7, 8, 9, 10. You know what? I'm just going to guess at this point. Okay, I don't want to sit here and take a super amount of time. 20, 25, 30, 35. 1, 2, 3, 4. No, it's right here actually. 1, 2, 3, 4, 5, and 40, and whatever. That's probably 45. That's good enough. All right. So on one hand, the temperature can be 5 degrees or warmer. So we're doing a closed boundary point here on the left, but it has to be left. So guess what? And this is perfectly reasonable. One boundary point can be closed. So here's the closed. Here's the open. They don't have to, there's no such thing as getting them to agree. They're completely separate things. Okay. You can definitely have one boundary point that's closed, one boundary point that's open. It's perfectly acceptable. Let's go back to me using a straight line for sake of neatness. Whoops, that was not neat though. Change it to straight line. Okay, a little bit crooked. And we're good, okay? And yes, there's your boundary point. You can slice them this way. Any temperature in here is good, right? You can play any temperature here is good. But you're not playing because this is too cold and this is too hot. So no good over here. Okay, you must be between the ages of 7. I'm going to switch to purple. You must be between the ages of 7 and 17 to do this activity. All right. Okay, so let's pick this as 5, 7, 8, 9, 10. 15, 20. I probably didn't need to actually use this number line. That's okay. This is a good lesson on scale, right? Did I need the number line to be this small in terms of tick size? No, probably not. That's okay though. No worries. You must be between the ages. So the age, again, you have to be older than 7. Being 7 is not acceptable. However, this type of question always provokes arguments, grade 9s. Because inevitably you get a student that says, but Mr. Smith, what if the student is 7 years old in 1 hour? Yeah. All right, whatever. Anyways, technically speaking, 7 is not an allowable solution. There's 7. And you have to be less than 17, 16, 17. Okay, let's straight line this. All right, so there's the boundary point. Again, I'm not going to get too fussy about it. And there's my boundary point there. All right, so You know, if you're 8 years old, if you're 9, if you're 10, if you're 11, you're 12, you're 13, you're 14, you're 15, and you're 16. You're good to go. All right? But no, this is too old. And this is too young. Okay, I think that was my last example. All right, that was my last example. All right, hopefully you get it. Once you get it, it's just the newness of the concept. I think most of you really get onto this pretty quick. Okay, I think I might have one more video, maybe not. By the way, my titles might have been wrong in a couple of videos where I said graphing equalities. Everything about this unit is inequalities, not equalities. We just spent 2 months on that. Inequalities. Anyways, thanks, grade 9s. Have a good one.